Good morning, student. Today we are going to learn about layout design rules. After completion of today's session, you are able to define layout, discuss the requirement of layout design rule, classify the layout design rules, discuss the types of layout design rules. What is layout? Layout is the representation of an IC in terms of planar geometric shapes which correspond to the patterns of metal, oxide or semiconductor layers that make up the components of the integrated circuit. So simply we can say layout consists of billions of rectangular shapes. So this is your example of layout. This schematic layout where the layout is represented by rectangles corresponding to the different objects, and we use some color coding convention to represent them. This blue means metal, red means polysilicon, green means N diffusion, yellow means P diffusion, and this black points are denotes the contact cuts. So different colors are used for different material so that it is easy to identify the materials. So what is the requirement of layout design rule? How do we know that the placing of the rectangular shapes are proper or not? Because due to imperfections, it might lead to the failure of the circuits. For proper placing, some design rules are used. These design rules act as some kind of an interface between the designer and the person who is actually fabricating, that is the process engineer. So design rule is a geometric constraint imposed on designers to ensure their designs that function properly and reliably. Design rules for production are developed by process engineers. So, layout design rules are introduced in order to create reliable and functional circuits on a small area. Main terms in design rules are width, separation, and overlap. Design rules does represent geometric limitations for an engineer to create correct geometry of the design. So, for checking the correct design, electronic design automation is used. Electronic design automation is used extensively to ensure that designers do not violate design rules, and the process is called design rule checking. In short, the design rule checking is known as DRC. DRC, design rule checking. DRC is a major step during physical verification on the design. Design rules are a series of parameters provided by semiconductor manufacturers that enable the designer to verify the correctness. The most basic design rules are shown in the diagram. So, this part. This is a single layer rule. Here, the width rule specifies the minimum width of any shape in the design. Then spacing means gap between two rectangles. A spacing rule specifies the minimum distance between two adjacent objects. Then this part. This is a two-layer rule. So this is a two-layer rule that specifies a relationship that must exist between two layers. For example, an enclosure rule might specify that one object of one type, such as a contact, must be covered with some additional margin by a metal layer. So, the design rules do not represent strict boundaries which separate correct designs from incorrect ones. A layout which violates some of the specified design rules may still result in an operational circuit with reasonable performance, whereas another layout observing all specified design rules might result in a circuit which is not functional or has very low performance. So, it observed that the layout design rules significantly increases the probability of fabricating a successful product. So, classification. The design rules are usually described in two ways, that is lambda rules and micron rules. The lambda rule that have been used is called scalable, means these rules can define in terms of a parameter, that is lambda. The value of lambda is half the minimum of the channel of the smallest transistor, means the channel present in the MOSFET. The lambda value is the half of that channel length. As technology scales down, means assume that from 0.25 micro technology scale down to 0.18 micro technology, then our design rules have not changed, but the value of lambda has changed. But nowadays, the scalable design rules will not work. There are some other design rules which are also used based on some absolute values, that is micron rule. So, lambda rule specify the layout constraint in terms of a single parameter, that is lambda, and the micron rules specify the layout constraint in terms of absolute dimensions in micrometers. So, this is a layout. In this layout, some R values are mentioned, that is from R1 to R20. That R values are the rule number. So, R1, this one is the R1. R1 is the minimum active area width, that is 3 lambda. As we know, the lambda values are already predefined by the process engineers. So here R1 is 3 lambda. Then R2. R2 is the minimum active area spacing, that is 3 lambda. Then R3. This one is the R3. This is minimum polysilicon width, that is 2 lambda. Then R4. It is the minimum polysilicon spacing, that is 2 lambda. Then R5. Here is the R5. That is minimum gate extension of polysilicon over active region, that is 2 lambda. Then R6. So Where is the R6? This one, the R6. It is the minimum polyactive edge spacing, that is 1 lambda. Like this, all other rule number have some predefined values. So here it is given in terms of lambda rule. If we use micron rule, then the values are mentioned using some absolute dimensions in micrometer. So this is all about layout design rules. Thank you.